What are I/O ports in microprocessors? Imagine trying to connect your computer to a printer, a keyboard, or a sensor. How does that connection happen? That's where input-output ports come into play. They are the gateways that let a microprocessor talk to the outside world. Think of them as the microprocessor's handshake points with external devices. These ports are made up of pins on the microprocessor chip, each pin capable of sending or receiving data. For example, an 8-pin port can handle 8 bits of data at once, which is like a small bundle of information. When a pin is set as an input, it listens for signals from devices like switches or sensors. When set as an output, it sends signals to control devices like LEDs or motors. There are two main ways microprocessors handle these ports. The first is called isolated or port-mapped input-output. Here, each port has its own address, separate from the main memory. The microprocessor uses special instructions to communicate with these ports. This method allows for many ports, sometimes over 65,000, like in the Intel 1686 microprocessor. The second method is memory-mapped input-output. In this case, the ports share the same address space as the memory. The microprocessor accesses them just like it would access memory locations. This makes programming easier but requires careful management of addresses so the system doesn't get confused. Electrical features of these ports are also important. Each pin can only source or sink a limited amount of current, usually around 10 milliamps. This means the port must stay within these limits to avoid damaging the microprocessor. Many ports have built-in features like pull-up resistors, which keep the pins at a stable high logic level when nothing is connected. This prevents false readings or floating states. In real-world systems, I/O ports are used for many tasks. They read data from sensors measuring temperature, light, or motion. They send signals to turn on LEDs, run motors, or display information on screens. They also connect to communication modules like UART, Serial Peripheral Interface, or Inter-Integrated Circuit, which are used for data exchange with other devices. Without I/O ports, a microprocessor would be stuck in a digital bubble, unable to interact with the physical environment. They are the vital links that make embedded systems work smoothly, bridging digital commands with real-world actions.